Welcome, dear civil engineering students and faculty members. So, in Galgotia University, we have next gen structural analysis laboratory, and I'm Dr. RameshBabu, working in Galgotia University. I will be explaining you about the calculations of horizontal reactions in three-pinned arch. And here we go. So, the professor myself is explaining about the theory behind the three-hinged arch.
That means the application of the load, the length of application of the load is less than L by 2. Now in the second case, the load is crossing L by 2. तो लोड कहाँ पर आ रहा है, यहाँ पर आ रहा है, तो ये L by 2 के मतलब ऊपर है, ठीक है. तो दिस इज LA greater than 0.5 L. So इनके लिए जो फॉर्मूला है W अप्लाइड है and you divide it by 2 है, it's multiplied by L minus LA, that is equal to R. Okay, these two formula will be used to calculate the reactions. One formula is for LA less than L by 2, another formula is for LA greater than L by 2. Okay, then you have to substitute here the value of LA in millimeters. Then you substitute the value of mass in grams, force, length, and h, everything. Then finally the load is
Explaining about the theory behind the three-pin arch, the students will do the manual calculations to find the horizontal reactions. So that is being explained here, and the students are performing the evaluation and calculation of the horizontal reaction manually. These calculations will be compared with the values shown by the machine.
L is 0.5.
So these students, they are keenly interested in learning the theoretical calculations as well as the machine calculations. So proceeding further, you can see that the experiment is being explained by me to the students who are watching about the values to be entered in the data acquisition system, which is provided by the VDOS software. So this VDOS software, the students will be performing the experiment on three-pinned arch. They will be applying loads starting from 100 grams to 500 grams. So maximum load the machine can bear is 500 grams. The machine is having a load cell which will only detect the horizontal reaction, that is for the applied loading. So whenever the student is going to perform the experiment, he has to do the manual calculations and verify the same with the experimental values. So here goes the theory. So you can see that for case 1, this LA is less than L by 2, and for this the formula is derived as WLA by 2H, where H is the rise of the crown, and W is the load applied, and these RC, RA, RB, and RD are the reactions. Now it could be observed that this RC will nullify the effect of RD, and so they are acting in opposite directions, and the values of RC and RD are equal. Now this is the case 2 where the LA is greater than 0.5 L. So the student will use this formula to calculate the value of RD and RC. Finally, how he is doing the machine calculation is by providing these information in the data acquisition system, like dimension, mass, force, length, height. He will be getting the reactions according to the load applied. For example, this picture will give you the information that the load, the mass applied is 100 grams, and it is converted to force as 0.9810 Newton. Proceeding further, he will be getting the answer as reaction RD. Now, these are the tabular columns used by the students, and this is the measured RD, which is obtained from the experiment, and this is the manual calculated value, which is obtained from the manual calculations. The student also uses Excel sheet for generating the manual calculations. Now, these are the derivations for the reference to the three-pin arch, and you can see that RA and RB are derived from the usage of equilibrium equation. Proceeding further, the first case is LA less than L by 2. So this is the free body diagram. As you see, here you have got one hinge and two reactions, internal reactions, and here this hinge also has a horizontal reaction and vertical reaction. So proceeding further, you take moment about C equal to 0, and from this you get RC equal to RD equal to WLA times by 2H. Then this is the case second or the case 2 is LE greater than L by 2, and once the load crosses L by 2, you can observe that the lever arm distance between the hinge C and W is nothing but LE minus L by 2. Now, applying the same equilibrium equations, that summation of moment at C equal to 0, finally you end up with the calculation RD is equal to W times LA minus LA by 2H, which is equal to RC. So these are the two cases for LA less than L by 2, LA greater than L by 2, and the student will use this formula for LA less than L by 2 and calculate the horizontal reaction, and the second one is for LA greater than L by 2, and the student uses this formula for calculating the horizontal reaction. Yeah. This is all about the three-pin arch and how the student calculates the reaction of the three-pin arch, and how he compares with the calculation from the experimental values. Thanks a lot for watching. If you have any queries, please mention in the comment section. Thank you.